Okay, here's more help from the 9-3b classwork. This is number 28. Here we have a function y equals x times quantity x plus 1, all of that over x plus 1. We're going to look for our landmarks again, the same as we did in the last video. And remember, if we have to factor, we don't have to in this case, but if we have to factor, there are good tips. I spoke about this stuff in the first video. Okay, so let's move this over so we can see the whole page. So first we have to look for common zeros, which is a whole, x plus 1, x plus 1. Using the zero product property, I know what quantity makes this 0 is x equals negative 1. So when the graph is at x equals negative 1, I know there's a whole. So I write that down and keep that in mind. Vertical asymptote. Vertical asymptote is what other zeros of the denominator are left over. Well, there's none. So there's no vertical asymptotes in this case. Let's talk about horizontal asymptotes. Horizontal asymptotes, we do degree analysis on top and bottom. Well, there's two x's up here. If you multiplied this out, you would get x squared plus x, and over x plus 1. The degree of the numerator is greater than that of the denominator. If the degree of the numerator is greater, that means there's no horizontal asymptotes either. Now let's talk about x-intercepts. X-intercepts are zeros of the numerator. Okay? Well, you might think 0 and negative 1. Well, that's a little bit misleading because zeros of the numerator, it's after you cancel out the common zeros. So the only 0 of the numerator is at x equals 0. And as a matter of fact, if you cancel this out, look what's left over. This is actually a line. You know, y equals mx plus b. This is a line with slope 1 and y-intercept 0. So you can say, well, what's the y-intercept? It's at 0. That point, in this case, is at the origin. So we can graph this real quick. To see what the graph looks like, you have to cancel out the common zeros, and then whatever's left over gives you an idea. This becomes a linear graph, except with a whole at x equals negative 1. So this line right here, y equals x, is just the y equals x line, which is a 45-degree line. But right here at x equals negative 1, there's a hole in the graph. And that's it.